Welcome to the REWIRE expert interview series in which we talk about security within IoT environments in the context of zero trust systems of systems. REWIRE is a visionary 3-year project funded by the European Commission under the Horizon Europe program. The project envisions a holistic security management framework to safeguard complex IoT ecosystems during the whole spectrum of their life cycle from the design to the runtime phases. My name is Christiana Kiperunda from 8Bells, one of the partners of the REWIRE consortium, and I am delighted to introduce our expert for our third interview, Dimitris Papamartzivanos from UBITECH, member of the scientific coordination team of REWIRE. Welcome, Dimitris, and thank you very much for joining me today.
Hi, Christiana. Thank you very much for this opportunity to discuss about REWIRE and the interesting things that we are researching and implementing.
So, let's begin with an introductory question. Can you please explain what is the most urgent problem in cybersecurity research that you are trying to resolve in REWIRE?
Today's infrastructures, ICT infrastructures are not as they used to be actually. So today we have more heterogeneous devices comprising more complex systems and what we call today the systems of systems. So we have devices with different characteristics coming from different vendors, and we have really complex and rather distributed infrastructure that we need to safeguard nowadays. So we are not in this era where everything was centralized, but we have moved towards a totally decentralized world. So this means that we cannot capitalize on these legacy security solutions that we had in the past, and we need to ensure security and trust now, not at the back end systems and the cloud infrastructure, but we need to move towards the edges of the networks and the network infrastructure. So this is an urgent need, and we need to research about such kind of solutions that will build and provide this kind of root of trusts in at the edges of the networks. And in this context, REWIRE actually aims to safeguard the entire lifecycle management of the systems of systems. Actually, what we are trying to provide is a solution that can safeguard systems both starting from their design phase, but also extending to their lifecycle during runtime phase, covering these two aspects in one framework. This is our aim in REWIRE.
In this context, in REWIRE, you are designing one of the core trusted computing building blocks towards enhancing the operational assurance of smart systems, which is runtime attestation and integrity verification. Could you explain us the philosophy behind trusted computing, attestation, services, and the novelty that REWIRE brings?
Exactly. Actually, attestation is one of the main artifacts that we are trying to build. Attestation is a well-known mechanism in both in the scientific literature, but also in industry. There are many different attestation protocol variations. The aim of attestation is actually to provide a technical mean in order to ensure the integrity of a system. So these different variations that we have seen so far mainly can be divided into different categories. So the one category is attestation mechanisms that try to provide evidence about the integrity of static properties of systems. This is something that is, let's say, trivial nowadays to measure static properties like the signature of an operating system during the boot up of a system. But the other variation is the one that has to do with the attestation of the runtime behavior of a process, of a system. And this is much more challenging. REWIRE is focusing on both variations actually, but the real challenges come from the variation that requires the attestation during runtime. So what we are trying to do is that we aim to measure the properties of the system during runtime that will provide us the guarantees that a piece of the system, a critical service, for example, behaves in a legitimate way. So this challenge has been in the literature starting, I don't know, maybe from 2006, when the property-based attestation protocols came up. But still the question remains about how we can actually pinpoint these properties that we need to attest during runtime, how to extract them from the system, and attest them in a very safe protocol in order to be sure about the legitimate state of a device. In this, towards this direction, we are building several mechanisms like tracing mechanisms for capturing actually these properties that we identify as critical for the system. But it's not only this. REWIRE is also investigating on and experimenting and extending new roots of trust, like trust execution environments. We are capitalizing on Keystone, a new solution that can help us in building such kind of challenging protocols for attestation.
Dimitris, you mentioned some challenges that you face. Would you like to share with us more challenges that you have encountered and that you're currently trying to solve in REWIRE?
Yes. In this context, actually, we have several challenges to solve. As I said before, one of the main challenges is how to identify these kind of properties that we need to attest. And another challenge is, of course, efficiency. Since we are moving towards, as I said before, these systems of systems and distributed environments, these environments are comprised from devices which have limited resources. So we need also to provide novel attestation schemes which can be compatible with such kinds of devices. So in order to solve those challenges, REWIRE actually is the first project, to the best of our knowledge, that tries to converge two different notions: the formal verification aspects and the trusted computing technologies like attestation. So what we're trying to do and how we aim to solve actually these two challenges about the properties, minimization, and the efficiency. So we use verification, formal verification during design time phase. What we believe is that if we model the behavior of the device and the protocols during the design time phase and we have guarantees about their correctness, then we can actually minimize the software and the hardware co-design stack that we need to attest during runtime. So by utilizing formal verification, we will minimize the attack surface of a device, and we will have a minimal piece of a system to attest. Then, in this way, the attestation, we believe that it can become much more efficient, as it will target only a specific and critical piece of the operations of the device during runtime. This is the main challenge that we are trying to address. Identify the properties that we need to attest through formal verification and achieve some strict requirements for efficiency. These are the challenges.
What type of attacks can such solutions protect against? Considering also recent attacks that aim to use software to exploit hardware vulnerabilities, to steal sensitive information, bypass protection mechanisms, or even compromise the entire computer system. what types of computing platforms are affected by such attacks and that we're trying to safeguard?
Well, yes, as I said before, this transition from the legacy systems to the distributed systems of systems have also changed a bit the threat landscape that we had to deal with until recently. So we have moved we have shifted from typical, let's say, network attacks towards other kind of attacks like cryptographic failures, security misconfigurations, outdated components. This is actually reflected to the OWASP top 10 threats that are considered as the most prominent nowadays. And indeed, we are witnessing attacks that currently combine both software and hardware vulnerabilities in order to compromise the systems. So, in legacy systems, of course, the legacy systems that we know are vulnerable also to such kind of vulnerabilities and attacks. However, in legacy systems, we have the possibility, let's say, to add complex security mechanisms in order to protect those systems during runtime. But this cannot be done when we are talking about small devices with limited resources. So what we are trying to do in this context and to avoid, let's say, safeguard against this software-hardware combination of vulnerabilities is to utilize the formal verification methods that we said before during runtime in order to validate the software-hardware co-design of systems during the design time phase. So what we need to treat is to treat in a combined way the software and the hardware co-design in order to lead by design to more secure and safe solutions.
Based on what we have discussed so far, it becomes apparent the importance of security mechanisms as part of the overall hardware security. So in general, how do you think that REWIRE solutions can impact the overall industry targeting the deployment of heterogeneous devices as part of safety critical infrastructures?
As we said, we aim to approaches that can guarantee this software and hardware co-design by design time phase. So what we aim in REWIRE is to provide this kind of generic processes of system designing. Hopefully that this will actually change the way that the industry is building systems nowadays. Actually, we are moving towards the open hardware concept where the industry actually capitalizes on open instruction sets like RISC-V and so on, which is one aspect which is at the heart of REWIRE. And in this context, actually, we saw the applicability of REWIRE artifacts in very critical domains and use cases that are in the industry domain. So we are focusing, for example, in the automotive domain, the smart satellites, the smart cities domains, which are critical infrastructures where the industry is focusing nowadays. So, for example, we have novel solutions about the secure lifecycle management of in the smart satellites and smart cities by providing and distributing software updates. We have and we are developing solutions for increasing the resilience of vehicles in the automotive domain by providing solutions like process migration based on trusted execution environment state migration. We offer secure communication in smart cities, even in the presence of physical attackers. So these things are really connected to what industry needs. And we try actually to provide as more generic schemes as possible in order to be able to be integrated and adopted to the processes of the industry.
Dimitris, considering that we are at the half of the project, are all goals that you had in mind as it pertains to the design of adequate security schemes been achieved?
Well, yes, we are, let's say, in the middle, at the half of the project indeed. It was, let's say, hard to reach this point until now. We are now in a really good state in the sense that we have identified and we have completed a very thorough list of security protocols that we are about to implement. So we have converged to the designs of the security protocols. And now it's the time that we are focusing on the implementation, looking toward to the first integration framework that we aim to release around this May. So the challenges that we had to face so far, actually, it was a really interesting journey because we had multidisciplinary background and several different processes that we tried to converge. We had experts from the trusted computing domain, experts from the theoretical cryptography, from the formal verification, applications in industry. The major challenge that we had was to converge on a common terminology and be on the same page. This has been achieved. We have this list of security protocols that we aim to design, and we have started now the implementation. And I think we are going to have really interesting outcomes at the end of the project.
That's great. And reaching the end of our interview, I would like to ask you if you have something else to add about REWIRE.
Not really. I'm pretty sure that this series of interviews will unfold many aspects, different aspects of REWIRE. I think today we covered slightly the part that has to do with the attestation and the trusted computing technologies that we are going to develop. Since we are progressing, I'm pretty sure that we are going to have other interviews that will see how these artifacts of REWIRE fit in the use cases, and will be really interesting.
Thank you very much, Dimitris, for joining me today, and I look forward to you again.
Me too. Thank you very much, Christiana.
Thank you.